Hello, you're welcome. My name is Thon Malek Garang. I'm going to take you through these tutorials on databases, and mainly we'll look at Microsoft Access Database because some of us might lack a background on the basic fundamentals of databases, basic background. So we are going to look at the theory, the basic theory first before we actually look at the hand-ons. So these tutorials are sponsored by National Geographic Society. I hope you will enjoy as we move on. Microsoft packages training, database management systems, and let us look at the theory before we embark on the practical part of it. What do you expect here? The learning outcomes, define database management systems, explain functions of database management systems. That's what you expected. You also look at, it should be in position to know the advantages and disadvantages of management systems. Describe the SQL database language and types of keys. Explain database design and normalization. Explain entity relationship modeling. As we go along these tutorials, you monitor in a way that this is how we will monitor the learning outcome, and this is what you expect from these tutorials. And then basically the assessment. So if you were to access or you do self-assessment, yeah, how would you know, how would someone know that you have understood significantly? That is, if you have understood database management systems, you understood functions of database management systems, you also understood the advantages and of database management systems. Of course, here, you are not going to be accessed in a formal setting, but just assume that if you are to access yourself, just evaluate yourself, assess yourself through this. Have you understood the database language and types of the keys? Have you understood the database design and normalization, understood entity relationship modeling? That is how you will access yourself against the learning objectives. Okay, let us come to definition of database management system. We say database management systems is a collection of interrelated data and a set of programs to access those data. Yeah, this is the basic definition we can give at this point. You have data which is interrelated, that they have a given relationship, and there are also some built-in programs which are used also to access that data. A database management system is not necessarily a database. A database management system is this a broader perspective, and let's say a platform that houses databases. That what I would say in this case. So if you come to the database, you will look at the collection of data, usually referred to as the database contains information relevant to an enterprise. So the primary goal, what is the goal of the database management system, is to provide a way to store and retrieve database information that is both convenient and efficient. So you look at the database management system as a house, and within the house, we are having different rooms, which we will consider in this case as tables. And within the rooms, we are also having different components. Consider you have a cupboard, you have chairs there, you have bed, and many other things. So you will consider some of these things. If you consider, let's say, a fridge in your room, if you open the fridge, you will find you have stored several items there inside. So consider database management system as a house that contains rooms. And within the rooms, we have a number of items inside there. And the items can also be described further. So as we go along, you will get to understand, and you look at functions of database management system. So it gives, let's say, a user or the developer an opportunity to define the database structure. That is where you have to define who should access which resource. Yeah, to authorize the users who will be accessing a particular resource. We should also be in charge of many other roles within the database. That is a function of database management system. You can as well manipulate the database. That is to say, if there is a need for an update, a deletion or retrieval from the database. As we say, for instance, if my name is Thorn and someone wrote Thorn with Thorn, so If it has to be updated, that is under manipulation to correct it so that it stands as THON. And also you can share database. They even share data items for multiple users by maintaining consistency of data. If authorization has been given from this part, knowing who should access at what point, so even sharing this, some of these services and the resources at this point is possible, and that is true. And consider protection of database. Yeah, there are tools which actually give uh, which actually protects the database, and that is actually given by this. How do we know who should access this? And if someone who is trying to access the database has not been authorized, what happens? So there is a mechanism in place that does that, and is actually done by database management system. Even database recovery as well. A number of technologies are in place. You can configure in the way that automatically at the periodic, at the given period, you have a backup of that database so that in case of any issues, then you can recover the data. Advantages of database, you can do the reduction of the redundancies. That is to say, for instance, if you are, for instance, let's consider a student database where you belong to different departments. You go to the accounts office, you go to the, let's say you can go to the clinic at the university, you go to many other departments. So in case, instead of them having every other data about you, your name and everything, so you just remove that duplication, so they will actually access the centralized data, whereby let's say these tables or these entities are related in the way along and they carry your ID. Sharing of data, a database allows sharing of data under its control by a number of application programs or user. That is an advantage. You have one database that is being shared. As I just earlier on said, that you have actually registered with the finance at the department, and at the same time, you go to the university facility dispensary. So in this case, because they share the same data, your name will be appearing on the other side and you will be in position to get some of the services. So data sharing is very important. Data integrity, that is to say that data integrity means that the data contained in the database is both accurate and consistent. Yeah, and that is an advantage, that if the data that has been fed into the database management, into the database is consistent. And how do you ensure that the data is consistent? There are mechanisms in place to check the conformity of data to some rules, and even data security as well as defined by database administrator. So we have, as we have talked about what database management system can do, we also look at how does it do it. We have the structured query language. The structured query language belong to fourth generation command that deal with manipulation of data present in the database. So we will be looking at how, if update is being done in session and viewing, how is it done? This is the language responsible, and there are a number of it comes along with different categories of commands, which is data definition language, data manipulation, and data control language. As we go with data definition, we look at the database. Yes, you have your house as the database management system. There are rooms, which are tables. And inside the tables, there are fields inside. So how do you even create them? This is what data definition language does. That is to say, now we have our table, which is book, and this table belongs to a given database. So you have to look at the ID, which is the primary key in this case. What is the title of the book? What is who is the author, and the publication and the subject. So the creation of these fields, I can call these fields, these attributes, is actually done by data definition language. You're actually defining the structure of the book, which is the table book, which belongs to the database. So that database, you can name it book, and to avoid confusion, you can also name it in a way that it gives you a level of, it gives you some way of differentiating them. And the same applies here. If you are creating a table which is called employee, you are using data definition, you want to look at what is the ID, how much are you giving to this ID? That is, here you are saying 10. Yeah, that is the length of the ID. which department does this employee come from, and you define whether all this should be an integer or a character. Here you have a liberty. Mainly for my case, when I'm designing databases, I look at if a value is not incremental and it should not be, it is not used for calculations, I always put it as a character, a variable character. Employee name given 40 because the length somebody can go, someone can have, so let's say a name which is a little long, first name, second name, and third name, or surname in this case. An employee address, which could be 50. If you say you put somebody's ID, you can even put it, but it is your intuition to look into it, that how length is an address. So this is your decision in this case. By having this table, which is having employee ID, department ID, employee name, employee address, we have actually defined a structure of the table in our database, and this is what we call data definition language. We are actually arriving at this because we are using that language to define all this the structure of the table, and this is what we were using to create the table. Yeah, you can also add a column called price. Yes, you can also do a dropping, you can do the deletion, you can do the altering. All these fall under this. The next one is data manipulation language. After we have looked at the data definition language, which was dealing with creating the database, doing that let's say creating the database, creating the tables and deletion. Let's say we saw it there, dropping, we also and altering. Now we are coming to data manipulation language. Now that you have your table, and the table is in a structure as we saw it before. So when you are entering data in your table, you are entering whatever you want to enter into the table, you have to manipulate that. That is to say, you can insert, you can delete, you can do a number of modifications within. So this one is actually done by data manipulation language, DML. It is a language that enables users to access or manipulate data stored in the database. Yes, so that is the work of data definition language, as we are going to see it. That is to say, you are going to select from the table, say select from this my table called employee, where employee ID is that you insert into the table, you can update, you can delete as well. You have seen deletion has also come to this part as it was in the part of the definition, data definition. So here you're actually manipulating the database. Like for example, here select name, author from book where author equal to P. Jones for specific. You want to select that. You can even say update if you want to update that. Update set employee equal to this and all that. Select from employee. So here you are doing the manipulation, and that is the work of this part. You can also do insertion, that insert a new row called employee name as Smith Peter. Insert into employee name Smith Peter, and all that. That is what data manipulation language does. Using employee table, you can also do the update employee. You set employee name equal to Stella Joseph, where employee name is equal to Smith Peter. So as at the point of records, capturing the records, maybe there was an issue in capturing properly the name of that particular employee. At first, you capture Smith Peter, but the real name is Stella Joseph. So you will actually update, and what will enable you at this point is data manipulation language. You can also delete as well. You say delete employee where employee name is called Stella Joseph. In case there's any duplication, you can delete that. Say I don't actually need that. You can delete or you can update. Now look at the type of keys. We have actually looked at the database as a big house, and within the house there are rooms. And within the rooms, there are specific components. We actually gave an example of a fridge. Now, there are specific keys which are used to manage this environment of a database. Yeah, and the database now is in a database management system. Now we have a super key. A super key is a set of columns that uniquely identifies every row in a table, while a key is a minimal set of such columns. For example, you have your employee, you say employee ID, employee name. For example, I have 001 and it is, my name is Thorn. So in this case, you would say this is a super key, where employee ID is a key, uniquely identified by a particular employee. Combine the name and the employee ID. The employee ID is unique identification. You will never find another person 001 in the company or in an organization or in that school, which is a student ID in this case. So that is a super key. And we don't need to confuse this one with a composite key, which is going to come employee ID and employee name. Coming to composite key, a composite key, you have one key which is not in position to uniquely identify. You have to combine different keys. For example, if I have employee ID 001, when you combine with the department ID, it is easier to uniquely identify that particular person or that particular employee, because it is possible you have an ID, and this is what I would just give it as an example in the environment of learning. You have learned database management systems in a fall semester. Now, at the university or the college where you are, they want to know the students who have learned that. So if you query that, we want to know students who have learned, who have started a database management system in the fall, then it will bring everybody who has been studying in fall, because that one is not enough. So you need to put the fall semester and even the year 2021 for the case of last year. And now 2021. So it is actually going to isolate. Yeah, this is a fall. Yes, what is the year 2021? So it is actually going to isolate 2020 and the rest of the other years which are coming. So 2021 and and database management system ID would actually work together as in this case as composite key, because the composite key comes in a way that one key alone is not enough to uniquely identify someone. Yeah, here we come to employee ID and department. Getting the employee ID and the department. Look at the, let's say, consider a situation whereby you have employee 001, and then say which department does this employee belong to, and then you look at the department, then you uniquely identify that primary key, unique identifier. So if for a primary key using employee table, the primary key is employee ID. A primary key is never duplicate. It is always just that one unique identifier of that record in a table. So when you look at a foreign key, is a set of columns in one table, which is a key in another table. At some point, some learners confuse a foreign key. What is a foreign key? Just let me give you a scenario in this way, that you consider your country, but your country has an embassy in another country. So that embassy is a foreign key. Though all the employees, those who are working in a different country, they are students, if you want to get anything about your country, it is through your embassy, which is led by your ambassador. But that embassy relates to your country back home. So foreign key is a primary key of one of this table, which is being placed as a representative, as an ambassador to another table, so that it can relate the two tables. That is how I could break down this foreign key. Just take it as a foreign key. How would I know that, let's say, who should be the representative to take it at that? So department ID in employee table that links employee table and department table. Now we have employee table, you know employee ID, but how do you know which department does this employee belong to? It is by bringing an ambassador from a department table, which is department ID, so that this department ID in the employee table can relate. So in this case, department ID is a foreign key, which is a primary key in the department table to relate. That is so that you can know which employee belongs to which department. What are some of the considerations which you take in this case in database design consideration, especially under normalization? So you will look at good database design is critical for ensuring that the data that we want to store is consistent and can be retrieved, updated. Here we are looking at how the data can be organized in a consistent manner and can also be organized in the way that uh, let's say, obey some of the rules as we are going to look at the normalization process. So there are factors to consider during the process, some of which are as follows. Let's say you consider as you design your table, how many tables should I have? Okay, how are these tables related? That is the questions of asking, okay, we have the department and we have the employee. How do they relate? You say, okay, I need to know the department employee belongs to. Okay, that's good. How many columns should each table have? Okay, I'm designing the table for employee. So how many should it have? Okay, I will get the name, I will get the age, I will get the ID, I will get date of birth, I will get this. So you count all that and you get to know how many should each table have. That is department ID and all this. Those attributes, those fields which it should have, you also consider them. Which columns should be the key columns? Now that I have all this, should I consider the name as the primary key? If someone is called John, another John will be employed in the future, another John will be employed after 10 years. So is it uniquely identified? No, I will go with the employee ID in this case. So those are design considerations. Coming to database, you have some of the good concepts here which will enable you to narrow down your database. We have functional dependency. Functional dependency is critical in formulating database design for two columns. If you say that, okay, that is when you look at the functional dependency, column B is said to be functionally dependent on column A if given A can precisely determine B. If you know one, you are able to know the other. For instance, let me just give you an example before we could go to the breakdown on this example here. If I say, for instance, the sum, the product of two numbers, let's say is 6. So obviously somebody can say it is 2 times 3 and 1 times 6. Yeah. So once you say it is 2 times 3, automatically you will get 6. So if you can determine the column based on the knowledge of what, if you can determine the other cell based on the knowledge of this particular cell, there is a functional dependency in this case. So if you know employee ID, you know employee name. That is automatically because these ones relate. This should be read as employee ID functionally determines employee name. If you have 0001, you say this is Thorn. Yes, by knowing that. If you have employee ID, you can determine address. And if you talk about address, it should be narrowed down in a sense that assuming that your address captures that particular house where you stay. But if it is a general address pertaining the area, no, that might not be the case. So let us come to this part here where we look at the employee database design and normalization. Come to employee table. Look at employee ID, employee name, age, salary, project ID, completion date. We are going to look at it practically later, how the naming above of the headings they matter a lot in terms of how you query your database. But let us just consider them that way. When you look at employee ID, for instance, A101, Anand Joshi. So in this case, you see, look at the age. So you look at that whenever it is A101, automatically you will know it's a Anand. When it is A102, you know it's Shilpa Kamat. Are you seeing that? So you keep on knowing that. So what is happening here? Employee ID, once you know the employee ID from this part, you are able to know the project ID. For example, if you know employee ID, say A102, it is WAP. You see, and A103 is WAP. So that is it. When you look at the project ID, there's a functional dependency at some point, which is completion date. Look at the project ID WAP, it is going to be complete on this. Whenever you see WAP, the completion date is that. There is that functional dependency. So normalization comes in now as a process of successive reduction of a given set of relations to a better form. That is to say, we try as much as possible to remove abnormalities in the table design so that our database will be consistent. Yeah, and that's why we have the normalization in place. Let's consider order number, order date, customer number, item name, quantity, and unit price, bill amount. So if I purchase, you say order number 1, order name to customer number 001. This is what I purchased today. And then tomorrow they will also put that. So there will be a duplication in this case. So that's where normalization comes in and say, the table identifies an order based on the order number column. Similarly, customer number can identify a customer, and item number can identify an item uniquely. But remember, all these are in the were in the same table. Notice that for a given order, several items repeat. Therefore, many columns associated with an item, such as item number, item name, quantity, unit, price, and the bill amount, also repeat. That is that duplication. And another issues with the first, let's say, at that point also, if when we come to the first normal form, we'll be considering the cell. If one cell can contain one value, then it is not in the first normal form. So let's say a table in the first normal form, if it is not, a table is in the first normal form if it does not contain any repeating columns or repeating groups of columns. You make sure that columns actually don't repeat. That is what is considered to be in the first normal form. And one cell is containing one value. So we have noted that in the order table, one order can contain duplicate items. You see, clearly this violates the principle of first normal form. So you just refer to that table and you look at it clearly. Now, as we break it down on the other side, we look at all those are duplicating, you remove them and create another table. And what are the repeating columns in the order table? They are item number was repeating, item name, quantity, unit price, and bill amount. So you remove them and create a different table in this case, just like this. You have the order number, order date, customer number. On the other side of order item table, we have item number, item name, quantity, unit price, bill amount. Don't forget our idea, the one that we introduced before of the keys. Like now order number, we have order number here is a unique key here, and the other one item number. But these tables are going to relate if they are going to make sense. For instance, we have here order number is being taken from order and put as a primary key in the order item, so that it actually knows which item was ordered. Yes, so it is easier for us to know that order number is primary key in the order table and a foreign key in the order item table. That's what I was talking of before, the analogy of an embassy, an ambassador. We remove this order number. We actually don't remove it, but we transfer it as an ambassador to be here so that we know that this one belongs to this country, and all the information can easily relate, so that we relate the two tables, and that's where the relationship comes in. So entity relationship modeling techniques used to model the data to be held in IT systems. And we have actually data modeling concerned with identifying and understanding the data items and the grouping of the attributes. These attributes are also called, the attributes in this case can also be called as fields into entities. Entities are the same as those tables. The relationship between the entities, that is the data modeling, and that one can be depicted through the ER model, that is entity relationship model. Now coming to the attributes, we have looked at the database. We have looked at the tables, and we look at specifically now the attributes, which we call as fields. So if you have an entity, which is, we can say an entity, which is a book, which you can call a table in another way. So what are the attributes? What are the other characteristics or the features, if we can break it down to that? Or what are the fields? What is further description which you can give about the book? You can say a book has a title, a book has an author name, a book has a publisher, and a book has a price. Those are attributes on that particular, and those are what you should know. You should go as much as descriptive as this particular entity allows you. And if you come to employee, you look at it, employee may be identified by it to be like employee number, employee name, age, gender, and all that. Those are features, those are attributes, those are fields on a particular entity called employee. Now coming to entity relationship modeling, which we are calling ER model. So a relationship is a relevant business connection between two entities. We'll be looking at there is a one-to-many, many-to-many, and one-to-one, the relationship which exists. As we have looked at the concept of primary keys, we also look at the concept of foreign keys. Now we are going to look at how these different entities are going to relate to one another. The reason being that we are trying to develop a database which will be consistent to remove redundancies and all these duplications. So we go to one-to-many, many-to-many, and one-to-one as we explore them more. What do you look at when it is one-to-many? Relationships are often degree one-to-many. So an employee is allocated to exactly one office, but each office must have one or more employees allocated to it. That is a one-to-many. And if you go to, for instance, this is a description that we have. An employee is allocated to one office, but each office must have one or more employees allocated to it. That is one-to-many. A solid line indicates one and cow's foot indicates many. That is one-to-many relationships. If you look at further one-to-many relationships, it suggested that the two entities are matched and one of the identifiers is selected to identify the matched set. Typically, the identifier that is created first. Now, a diagram showing a one-to-one relationship. Now consider that we have an order is related to one invoice. One order, one invoice. So if you are buying so many items, you buy this time, you buy a computer, you send one order and an invoice for it. Another one, you buy, let's say, a smartphone, Samsung, and you also get an Apple product, you get so many of them. And so each invoice is related to each order. That is the one-to-one relationship. The relationship between two entities is exactly one-to-one. A solid line is used to indicate one-to-one relationship. If you need to know exactly, you just look at a situation whereby you purchase several products. You buy one today, you get its own invoice, you pay for it. You also buy another one, you get another invoice. So that is exactly one-to-one. Many-to-many relationships, which is indicated M, this full colon M, occur frequently. For example, an employee may be contracted to work on many projects, and a project may have many employees contracted to it. You see, so you are contracted maybe to work on these projects, so many projects, but even within, you find that even one project has many employees. So it is many-to-many relationship. So it is indicated like this: an employee may be contracted to work on one or more projects, and a project may have one or more employees contracted to it. That is many-to-many relationship, which is also further explained here. Many-to-many relationship can be problematic because they may mask omitted entities. Most database management systems do not support many-to-many relationships. So we have the entity relationship diagram here, or modeling diagram showing a decomposing many-to-many. So we have many-to-many relationships are normally decomposed into one because we have actually explored before, there are issues that come along with that. So to better make it work, it is decomposed into one. An extended structure showed that an employee is linked to one or more contracts, and a contract is for exactly one employee, while a project is linked to one or more contracts, and a contract is exactly to one project. So this work will be available, these tutorials, so that you grasp them the more and you internalize as you explore further on some of these concepts. Thank you. I wait to see in the next part of demonstration so that we explore more about database management system, especially Access database. If you feel that this tutorial was useful to you, please like it so that I see how I can frame it or find a way of recording some of these videos based on your input. Thank you.